for the IOTA platform, one of my favorite people to listen to. Please welcome Paul.
Thank you. All right, thanks for the impromptu invitation, Dan. I love to hear the sound of my own voice, and I love to talk about IOTA. Perhaps show of hands, how many of you have actually heard of the IOTA project? Oh, good. All right, so I'm not a complete crazed lunatic. Mostly, though. So, IOTA is, for the rest of you, IOTA is a bivariate directed acyclic graph. It's a distributed ledger, as opposed to blockchain, which is a univariate directed acyclic graph. This has some consequences. Let's go next. So the Tangle, it does not have blocks, and it does not have a chain. It is a mesh structure. It is kind of like, well, kind of like a fishnet. It can look kind of like this. A white paper was written at the end of 2015 by Dr. Sergei Popov, a research mathematician in Brazil. I can't remember the name of the university he's at. Very, very nice fellow. But we have the Tangle. Instead of having multiple people compete to be the leader in the consensus, which is not proof of work. Proof of work is not consensus. Proof of X is not consensus. It is simply an anti-civil measure. In the case of blockchain, proof of work is an anti-civil measure to see who gets to be the leader to make the longest chain. Blockchain, the consensus mechanism is longest chain wins. In IOTA, basically, the consensus mechanism is greatest weight wins. Where if we look at this, here's a site in the graph. This site has a weight of, in our case in IOTA, that weight is 1. There's the generalized principle in Tangle, which is the technology IOTA is based off of. You could say IOTA is to Tangle as Bitcoin is to blockchain. In Tangle, that could have a weight which is associated with the amount of work done on it. And in IOTA, it just takes a weight of 1. All right. No, I'm going to go back. I'm going to blurb about this for a little longer because it's interesting. So I'm really interested in this phenomenon that is IOTA because there are no miners in the IOTA ecosystem. There are only participants. We've unified the transaction producers with the node validators. It works like this. I have some money that can be discovered back here somewhere in the history. I want to make a transaction. I walk through here randomly. I actually do a Monte Carlo random walk, which is to say that I look at a site here. Say I pick somewhere that's sufficiently deep in the graph, and I calculate the transition probabilities to its children. That sounds like big words, but let's just say that this one has 10 transactions in the future that approve it. This one has 11. I move exponentially toward the one that has a slight difference in weight. And this is kind of how I walk through, and I find some tip at the end that is going to maximize the probability that somebody else is going to do the same to me. So instead of being a leader-based mechanism, and a competition-based mechanism is what we have in this miners always in the ever-competing ecosystem. We have this beautiful collaborative ecosystem that emerges from us just wanting to get our neighbors to recognize us. So how do you make a transaction? I guess you sign your transaction, you select the tips as I just described, and you do some proof of work. The proof of work is intended to limit the ability of a single actor to flood suddenly a certain portion of the network. And it actually has a really interesting way that it emerges in IOTA. So proof of work in blockchain, it's done, everyone does a bunch of work, and it's designed to select who's the leader. It's like everyone's battling to be the king of the hill. In this case, proof of work in IOTA is actually used to prioritize your transaction in broadcast to your neighbors. I don't think, honestly, since this is a bit last minute, I just stole these slides from one of my other colleagues, so I don't have probably what I'd like to be showing, but I'll use this as a, we have this as, this is the actual data graph, but the network graph is kind of similar to this. IOTA operates in a mesh network configuration. When you have a system like a blockchain, your main desire in communication is to get everything about your block that you just mined to everyone as soon as possible because you want them to recognize that you're the leader. In IOTA, it's actually not too bad to have transactions delayed because that delay actually helps us to mitigate attacks, and that allows us to keep those isolated. Because when, let's just pretend this is no longer a directed acyclic graph, but is now just a network graph. This kind of looks like a mesh network, I think. You may disagree, but let's look at this guy. Pretend he's a node in the network. These edges reference his neighbors. He puts out a transaction. He sends it to his neighbors. They all get it. And they have a list of things to broadcast. And the amount of work that I put out there, or alternatively, the interest that they have in it, but let's just go with work. The amount of work that I put into that is going to have them, they're going to make a list, a queue, and I just realized that I might not be talking to a developer audience, but I'm going to take this anyway. They have a list, and they put it in that list according to how much work was done. So transactions with very little work don't travel very far. Transactions with a lot of work propagate quickly to the edges of the network. I could probably rant about this for too long, but I suppose I shouldn't. By the way, anyone, if I'm kind of riffing this, so if you have questions, just raise your hand. If you call bullshit, raise your hand. And I love nothing more than to argue. Why is IOTA awesome? There's no transaction fees. When you have miners, when you have a third party that you have to interact with, you have to pay the third party to do something on your behalf. Money is something fundamental to the way that we interact with each other. And for this reason, IOTA, which is intended to be the backbone of the Internet of Things, took money from application layer, took it down into the network layer, not at layer 2, not at layer 1, at layer 0. At the propagation layer is where the money sits in IOTA. That's how important we think that it is. And because of the consensus mechanism that I just described, it's a very swarmy consensus mechanism. You don't have to pay anybody else. In fact, they are very happy when you add transactions to the ledger because you make it more difficult for someone else to attack the network against them. It's beautiful for them. You want to add transactions to their part of the ledger? Thanks. You add it, they're grateful. If you added it to a point with sufficient significance, if you added it maybe to here, it's not going to help them. But when you add transactions to here, it's going to make your neighbors more likely to select you, and your addition there makes it exponentially more difficult for an attacker. There's I realize that this is a very business-oriented slide deck. It scales! In fact, IOTA is a more or less I think scale-free is a better way to describe it because as the network grows and expands and saturates, the saturation is actually a really interesting point because you get the amount of work that you need to do in a local area dynamically grows and shrinks. Some argue that it will grow exponentially forever. I disagree. Shoot. More and more people want to do more and more communication over the network, and what's that? There's essentially this suggestion that if there is space, people will use it. If there's bandwidth, people will use it. I mean, we see this in the cell phone network. Oh, what makes the network handle the exponential growth? So right now, the IOTA network, as it is operating on the internet. It's intended to operate in a sensor mesh net. So sensors which can only talk to sensors with which they have line of sight. So it's the IOTA over the internet mimics this with mutual tethering with its neighbors. And in this way, so there's no distributed hash table, no Kademlia, anything like that to discover peers. I mean, some people have built that, but they've built it with the idea in mind that you want to have a mesh topology rather than a star or a centralized topology. So what makes it scale is that everyone who's doing proof of work, for instance, right now they're doing proof of work with, it's the same proof of work as you do in Bitcoin. You collide the last n pieces of the hash of the data that you're attaching with the all zeros hash. The all zeros hash is something which no one knows the pre-image for, but ergo it's something that's that we can kind of all collide with. We call this cluster zero. As the network scales, it could perform mitosis of sorts, and this part's actually currently in discussion in the IOTA research group, and I don't know how much they appreciate me talking about it in a public forum, but I'm going to anyway, since you asked. So let's say that we're all operating on the cluster zero, and Subway downstairs decided that the network's too saturated. They're not able to get their messages out anymore because this is what happens as use grows, you get saturation. So they decide, well, I'm going to sign a transaction. I'm going to send it out anyway, and if it gets out, it gets out. So the people who see that transaction that Domino signs, and it has a transaction hash, but it does not collide with anything. But because it's important, it's Domino's. I mean, seriously, I buy pizza from them all the time. They will propagate it anyway. And that is you could call that a proof of real-world importance. Their ID is their resource, their public key. And from that they can grow, and it is completely at the mercy of the rest of the network to take interest in it. They can grow and decide to collide with the hash of whatever transaction that Domino's just posted. And then we can get this mitosis. So it would appear that we have a fork in the graph, but it still operates as one graph. These cluster zero, i.e. collide with zero transactions, and these cluster dominoes, whatever, transactions, they'll still reference. It's still the same tangle, and the people who moved over into here, they still kind of hear about the cluster zero transactions, and they still send to their cluster zero neighbors some of these dominoes cluster transactions. And as this grows exponentially, you have something called economic clustering, which takes over. So the rule in IOTA is, based on So I want to move forward exponentially based upon the proof of work determined weights. I can have other types of weights, and this is termed local modifiers by Dr. Popov. The idea is, I look at this, and I look at the graph above it, and I will look at someone like right here, Let's say this is a Domino's guy, and say this is 7-Eleven, this is whoever else, I don't know, Walmart. He looks up here, and a node has his own determination of what the importance of Domino's, what the importance of 7-Eleven and Walmart is. And those become kind of like votes, but not in the validator sort of sense. It's what moves the graph. But a person's going to move up toward Walmart. If Walmart's more important than Domino's, they're going to move toward Domino's if Domino's is more important. And these clusters can kind of end up looking like overlapping Venn diagram-like clusters. And you can see money moving into one cluster, but you didn't see where it came from necessarily because you don't sync that part of the network. But as it comes into that cluster, it's like the law of thermodynamics. You don't want to touch something that's hot because it hurts. And things that are hot kind of mess up the mechanics of a mechanical system. You want to wait until that's cool. So that comes in a distant cluster over here. It's hot. I don't touch it. I can see some people in my cluster recognize, people that I do business with. They're accepting it. They're using it, which means that they must consider it cool. By the time it gets to me, it should be cool. If it doesn't, I'm not going to let people randomly print money. However, it does actually necessitate to allow for tokens to be forgotten and tokens to be forged. That is for this to be operable in IoT and for it to be actually operate in a scale-free manner. It does require for those two things. So it doesn't actually have once we start seeing this emerge, it doesn't have a notion of global consensus. It's a localized swarm consensus. Does that answer your question, or did I just rant off in this? A bit of both. Well, give me some feedback then. What? Help me help you. Tangles? Yeah. It's all the main tangle in this case. Sorry about that previous image. It does look like that. Ignore that. It's all in the main tangle. I don't see everything. So let's pretend that a bunch of these are colored purple. No, what's Domino's color? Like blue-red. They're colored Domino's over here. They're colored 7-Eleven over here. Kind of adjacent. Oh, goodness. Is this still running? It is. They're kind of like, they're adjacent in that, so I mentioned previously that I have this broadcast queue, right? So I give, let's say I give 30% priority to broadcast the Domino's ones because I operate there, but I also go to 7-Eleven, so I give maybe 20% to 7-Eleven in the broadcast priority. So I see and I prioritize those ones. So it's like me and the people in my local neighborhood, we talk about that, and we don't really talk much about the other stuff unless it's really important. And really important in cluster 0 means it collides many bits of its hash with the all zeros hash. It's all the main, that would all be the main tangle. It would all be here, but your visibility of it would be like, I don't know, if you played StarCraft, you know, the fog of war? No? Who the hell am I talking to? I thought I was here with a bunch of nerds. Quick, someone, explain. You'll see some fuzziness, and some of these edges, you know what this is by the hash, but you don't actually look for the data because you recognize the data is from some cluster that you don't care about. So you only care about local consensus. And instead of having a global ledger which itself has a fixed supply, you have a set of local clusters or local tangles, which are all in here, and they're not even virtual. They're just there, and then there's some that they can't see trailing off in this direction. I mean, the main premise is, as a person in downtown Bellevue, I could care less about what some guy in Shanghai is selling on the street. I don't care about that. I only care about that. I care that the money in the area that I'm using it is going to be transactable. But yeah, it's all the main tangle. It all operates, and I actually still reference indirectly or directly these neighboring clusters. It's like this Venn diagram idea. But I see when stuff moves across clusters, they'll reference across clusters and all that kind of stuff. So I wouldn't say there's no more main tangle. It's all just tangle at some point. Please. It means that it's difficult to get in and out of it. So the Bellevue, if there's a Bellevue tangle and it's it is really just Bellevue and then Seattle. They kind of operate in parallel to each other, and there's traffic we expect going between the two of them. So we should see them doing this all the time. If they're not very connected to anyone else, it's just difficult to move money into them and difficult to move money out of them. And I think the effect of that is that you see more price volatility in terms of goods and services in Bellevue. Similar as we do with the dollar, it costs way less for me to go buy a burger in Bremerton as it does in downtown Seattle. That's the basic idea, I think. Does that help? All right. Anyone else, by the way? Don't be shy. And Dan, feel free to tell me to shut up at any point. All right. This is from a long time ago. More than $6 billion transacted. It's been going since mainnet's been going since July 11th, 2016, and this network doesn't really care about scale. As local scales, it can kind of go and do some mitosis. So IOTA is developed by the IOTA Foundation. It's a nonprofit Stiftung registered in Berlin. That means that they have to put up with a lot of regulatory things, but because of that, we have really good relationships with people like Bosch and Volkswagen, and I can't remember who that are public and who they're not, so I'll just not carry on with that name dropping. Our vision is a machine economy. We want to see, and I mean, the definition of machine economy really varies. To me, machine economy is I want to have these walls painted with trillions of IoT devices that communicate to each other via Wi-Fi or, I don't know, perhaps via longitudinal volts per second communication. Nevertheless, that they interact, they swarm, and we can allow for tiny, tiny amounts of tokens, like nanocents to be sent, such that we don't have to even consider the idea of fees and escrows anymore. We can manage our own economic risk in amount that we're willing to lose, which is, who cares if you lose a nanocent? The machine cares a little bit. The next sharing economy we'd like to see, like to see you be able to rent a car, rent out your drone if you have a drone. We'd like to see things where you can operate independent of network overlords. but really it's a machine-to-machine local economy. Some use cases, what do we have here? Car pass, share and charge. They're doing this thing in Europe, this Oslo to Rome project, and some people from, I think it's called Elan, Energy, these guys. They actually have some charging stations running on IOTA, which is pretty cool. And they have, secure. The idea, I don't know what's public about what, but you want to have like a secure audit trail for your cars. This data scales, and it can be passed along. And considering that some of these transactions are going to be more popular than others, you're going to prune your own history, but some important ones you're going to keep. And you can actually provide, if I say Merkle proofs, how many people know what I'm talking about? Bam, bam, awesome. You can provide, all you need to do is provide a trail to an inclusion to a popular reference that other people are going to recognize. So you can have pruning, and you can also have scalable data integrity, where the definition of integrity is prove that yours existed first. You could have digital identity for cars. You could have a charging network that operates. I don't think that your charging network needs IDs, but your cars can surely sell their data for charge. They've had this data marketplace running since last fall. They have some interesting participants who are posting their data onto the Tangle directly, just their sensor data. We have like some people running these Bosch XDK sensors, and they're posting that to the IOTA network in an encrypted manner such that you could then buy access to those data streams. We'd like to see people, we'd like to see companies, we'd like to see industries move away from siloed data and move to openly shared data, because when we share data, we all benefit. We'd like to see Industry 4.0. We'd like to see where, a little factory can organize with all the other little factories in town and manage to optimize their load such that they're always working at full capacity. Has anyone ever worked with a laser cutter, like an industrial laser cutter? Those things are set up, I'll just do a slight tangent. Those things are set up such that, you have a little kerf and you want to cut out a part, and then you're going to have some stuff that gets wasted. That stuff that gets wasted goes to a recycler, and it's one way of recovering the money, but a circle that's about this big and cut with some fancy design is worth tremendously more than a circle of waste. And if you can optimize your nesting on those things, you can really cut down waste and increase your profit. So it's a win for everyone. Supply chain tracking. There's some people who have done some stuff with supply chain tracking over IOTA. Again, I'm a developer, not a business guy, so I don't know if this is public yet, but they've done some stuff with tracking car deliveries between ports. Some people. Sorry, I have to be vague, but generally shipping liners, importers, exporters, these people, they've been doing this supply chain tracking over IOTA, and it's really handy because you can your transactions get tangled in, and it's very difficult to untangle them. So for the developers, ignore that actually. Sorry, I picked an old slide deck. Just check out github.com/IOTA Ledger. There's I think there's a new JavaScript library for those who do JavaScript. They're actually working on a C node. I think they call it C IOTA reference implementation. And 8 minutes. IOTA's main features, data security, MTM payments. I didn't know what's on my slide deck. An IOTA transaction, here's what it looks like. You have a hash of this data. Sir.
Yeah,
Awesome.
I had a question about the sharing elements you're talking about.
Yeah.
So I'm wondering, like, does IOTA as a token have features that make it more prone to being shared as opposed to Ethereum or Hyperledger, something, another token that's not readily shared in a community way?
What do you mean by, what's your definition?
Well, so I mean, like, you and I could send a Bitcoin or an Ethereum back and forth together, but we can't own it together. So
we can't own the token
correct.
together? Okay.
Yeah, is that still true of IOTA? Or can we own something together?
Oh, you mean like own a product or own a token?
Like fractional ownership.
Fractional ownership? Of a token? I don't think you can do fractional ownership, no. You can do multi-signatures, but
okay.
I don't know anything about fractional ownership.
Okay.
I mean, IOTA is, like I was saying, it's like a layer 0 thing. But some of the things that it enables, like you can look at economies in a different way. So now you have to have these escrow people who kind of manage things for you. With IOTA, you can do scalable micropayments, like what Lightning Network can't do. And that's all at layer 0. And instead of having to pay fees and escrows and all these complicated things, you can take a fractional loss, a risk of fractional loss. As you send me, like, let's say we go to a store, you want to buy a candy bar from me, well, you send me a payment. I don't wait for that to get confirmed, but I want to give it the highest probability of getting confirmed. I send it up to my vendor, the warehouse. They can send fractional payments out to their employees, and they can send it up to the factory. And, this cascades and makes it way more difficult for you to cheat me, but still, it's just like working with a group. I don't think that really answered your question, sorry. Cool. Awesome.
And
anyone
buying into fractional ownership of a collection of IOTA tokens sounds like an application, decentralized application.
Well, you could do that. I mean, later down the road, I'm working on something called Cubic. I guess I'll just skip to that. Order bundles. Actually, I'll do this real quick. You have a transaction. A transaction can have some data and has some information that tells you how it's connected in the graph. There is only 2 edges, and it is exactly 2, because I don't have to get into that. I only have 8 minutes, unless I have more. But we made this thing flash, so you can, this flash channels thing. Cool. I'm fine with that. Flash, you can actually take tokens off Tangle with multi-signature payments. Mass authenticated messaging. You have this thing where you can create a message channel with a pre-shared key, and you point forward to the next place where you're going to be publishing after that. It uses Merkle signature scheme. We want to be quantum proof because IoT never upgrades. And then we have Cubic. Can you play this for me? I don't know if that will do this. Someone made a video and I thought it was pretty cool. Maybe we can even get sound. Or maybe it's not even going to do anything. Nope. Oh well. I'll tell you about Cubic. So IOTA itself was designed to be something that your average run-of-the-mill IoT device, and IoT is not microprocessors. IoT is FPGA and ASICs. Your average IoT device can operate in. And so we had to leave out smart contracts and all types of complicated decisions, except for dealing with the graph and the ledger balances itself. So we had this idea that's gone back since 2012 called cubic, which is a alliteration of QBC, which is quorum-based computation. Or once upon a time, they called it quorum-based coin. Instead of having, let's take Ethereum, just as an example. When you want to make a state update in a smart contract in Ethereum, you pay a fee, you wait 17 seconds, and then you have your update. And really, you have this block size limit, and fundamentally, if you're going with global consensus, or really just in a longest chain type of situation, there's no getting around this. You can split up into multiple chains, but you still have a communication issue. It's, it's pipeline processing, and pipeline processing has a von Neumann limit. So, cubic is an asynchronous computational thing. Instead of setting up these difficult things that you have to do test, compute, we just separate that out, test, and all compute. So you have an epoch of time that you set and a resource test phase. And anyone who wants to join into a certain subset of computation, they do some resource tests in the resource test phase, and then thereafter they have an unbounded amount of computation that they can come to consensus about. And they do that with the coming to consensus is just the general way that quorum computation is done. If you're not familiar with quorum computation, in the resource test phase, we bind the participants to, say, 10 people. It could be 100 or 1,000. And then in the computation phase, you just have to have majority or a quorum come to the decision on the result of something. Interestingly, though, you don't have to wait for a quorum to come before you do the next processing step. So you can look at something, you can put in your vote, and then you don't have to wait for anyone. You can put in your next vote, and your next vote, and your next vote, and your next vote. You can run massive. You could run all the blockchains that you wanted on Cubic. I think that it'd be a bit silly to do. And I honestly, no offense to anyone, but I think the whole ICO craze has been a little bit silly. But you could do it, and you could do it at great scale. Not quite the scale of IOTA itself. You could still achieve the same things, but albeit you have to keep your little machines fed in this case, because Cubic operates as a way for machines to make profits. IOTA is also has this other unique feature or thing, quirk. It was spun off of a company called Gin Labs. They have this aim to make a trinary general purpose microprocessor. And as such, IOTA does not use binary, it uses trinary. Balanced ternary, 0, plus, and minus. This has the lowest radix economy of any natural number, and there's some various computational reasons that they made those choices. I yield.
Fabulous. Thank you, Paul.
Thanks, Dan.